In session 110, number sequences. We're going to be taking a look at what number sequences are and then some special types of number sequences. Basically, a number sequence is just a sequence or a listing of numbers, sometimes based upon a particular pattern, sometimes not. Here in our first example, 1, 3, 5, 7, 9, we have a number sequence here. We have a sequence of numbers that are listed. And to the right of the 9, we see 3 dots. Those 3 dots are called an ellipses. And what those 3 dots indicate is that this sequence, this list of numbers, continues on indefinitely. But we don't need to write all those numbers, obviously, number 1, because it's impractical. But number 2, in order to see if there's any pattern here, we already have enough numbers written down in our sequence to determine if there's a pattern. Well, taking a look here, our first number is 1, our second 3, then 5, 7, and 9. Do you notice anything that we did to the first number that would have produced the second number? Well, you could have said that we multiplied the 1 by a 3 to get 3. Okay, well that's valid, but see if that same pattern works for the next number. You're at 3 now, and if you multiplied by 3, that would give you 9, not 5. So the pattern here is not that we multiply each term by 3 to get our next term. What else do you notice here? Well, the difference between 1 and 3 is 2. And the difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And between 7 and 9 is 2. So what the pattern is that whatever term we started with, which is 1 here, we add a 2 to it to get our second term. 1 plus 2 is 3. Now that we are at our second term, 3, we add another 2 to it. 3 plus 2 is 5. Same pattern, 5 plus 2 is 7, and so on. So the question here is for our first number sequence, what would the next 3 numbers in our sequence be after 9? Well, we're going to take our 9 and add a 2. That would be 11. 11 plus 2 is 13, and 13 plus 2 is 15. When you have a number sequence where you add the same number to each of the terms to get the next number, we have what's called an arithmetic sequence. An arithmetic sequence is a sequence whereby you need to add the same number to each of the terms to produce the following term in the sequence. 1 is the first term, 3 is the second term, 5 is the third term, and so on. Well, here's another type of number sequence. 1, 3, 9, 27, and 81. What did we have to do to the first term to get to the second? Well, you could say the difference between 1 and 3 is 2, so we added a 2 to our 1 to get 3. Well, that's a valid strategy, but continue it on. If that is the real pattern, then we would also need to add a 2 to our second term. Well, 3 plus 2 is 5, and the third term that we have listed here is not a 5, but a 9. So our pattern is not that we add a 2 each time. Think about multiplication. What do we have to multiply the 1 by to get 3? Well, 1 times 3 is 3. Well, if we use that same pattern and multiply our second term by 3, what do we get? Well, 3 times 3 is 9. Using the same pattern, if we take our third number, our third term, 9, and multiply by 3, we get 27. 27 times 3 is 81, and then the 3 ellipses, and so on. If I asked you what is the next number in the sequence after 81, we would simply take 81 times 3, which would be 243. Now, when you have a number sequence whereby you have to multiply each term by the same number in order to produce the next term in the sequence, that's called a geometric sequence. Where you add the same number to each one is a arithmetic sequence. When you multiply by the same number to produce, that is called a geometric sequence. And down here, oftentimes when you deal with number sequences, we use the letter T with a subscript. A subscript is a number that goes a little bit below the letter T, whereas a superscript, oftentimes exponents, most of the time exponents are written as superscripts. When we have a subscript here, we're talking about a term in a sequence. So T1 stands for the first term in our sequence. T2 stands for the second term, T3 the third term, T4 the fourth term, and T5 is the fifth term in our sequence. So backing up, here's T4. What is T4 in our first sequence here? What is our fourth term? Well, you start at the beginning. Here's our first, second, third, fourth. The fourth term, T4, in our first sequence is 7. What's T4 in our second sequence? Well, T4 would be the fourth term over. That would be 27. So that's what the T's represent with the subscripts. Now let's take a look at another very simple sequence, number sequence here. First of all, what did we have to do to the first term to get to the second term? How about adding 5? Well, 6 plus 5 is 11. We're using that same pattern if we have to add a 5 to 11. 5 to 11 does give us 16. So what we have here is what type of sequence? What type of number sequence do we have whereby you add the same number to each term to produce the next one? We have an arithmetic sequence. What would the next two terms be? Remember, what's our pattern? Our pattern is that we're adding 5. So our next two terms would be 16 plus 5. That would be 21. And then 21 plus 5 would be 26. In this number sequence here, what is T3? T3 being our third term. That would be our 16. Right there. Let's take a look at another number sequence. 21, 12, and 3. This time our numbers are getting smaller as we go from left to right. So what did we have to do to the first term to get to the second? Well, we subtracted by 9. Well, subtracting by 9 is the same as adding by a negative 9. It's fine to look at it either way. So we had to add a negative 9, or we had to subtract 9 from our first term to get our second. Well, if that's the pattern that holds true for the entire sequence, then that needs to also hold true for our next term. 12 minus 9 is 3. So we can see that in this second sequence here, we had to subtract 9 or add a negative 9 to each term to produce the next. So then, what would the next two terms in this sequence be? Well, what's 3 plus a negative 9? That's a negative 6. And a minus 6 plus a negative 9 would be a minus 15. This too is an arithmetic sequence. You might be a little concerned because we didn't add here, we subtracted 9. But if you remember, in algebra, subtracting is the same thing as adding the opposite of a number. So we did in fact add the same number to each term here. The number that we added was negative 9. So this is another example of an arithmetic sequence. The question here, in this second sequence, what is T4? What is our fourth term? You start at the left, work right. Our fourth term is negative 6. Let's take a look at another sequence. 5, 10, 20. What did we have to do to the first to get to the second? Well, you could say we added 5. But if that's the pattern, then when we added 5 to 10, we should get our third term. But we don't. 10 plus 5 is 15. Our third term is 20. So adding 5 is not the correct pattern. What about 10 in relationship to 5? Not only is it 5 more, but 10 is double 5. So let's try multiplying by 2. 5 times 2 is 10. 10 times 2 is 20. So in this sequence, we're multiplying by 2 between each term to get the next term. With that in mind, what are the next two terms? Well, we have to take 20. Our pattern is multiplying by 2. 20 times 2 is 40. Our next term would then be 40 times 2, which is 80. When you multiply by the same number to produce the next term in the sequence, that is a geometric sequence. Lastly, let's see if we can determine something here. here's a sequence, a number sequence: 1/3, 2/4, 3/5, and 4/6. In this situation, are we adding the same number to the first term to produce the second, and then turning around and adding that exact same number to our second term to produce our third, and then adding that exact same number to our third term to produce our fourth? Well, no, that's not really what's going on here. But if you look, you should be able to determine a pattern. If you take a look at the numerators, our first numerator is 1, our second numerator is 2, our third is 3, our fourth is 4. What did we have to do to the numerator of our first term to get the numerator of our second term? Well, we had to add a 1 to it. What did we have to do to our second term in the numerator to get to our third? We had to add a 1. 2 plus 1 is 3. To get from our third term to our fourth term, we had to add a 1. 3 plus 1 is 4. What about in our denominator? Our first denominator is 3. What did we have to do to it to get to 4? Well, we had to add a 1. 3 plus 1 is 4. We turned around and added 1 again. 4 plus 1 is 5, and added 1 again. 5 plus 1 is 6. So the question here is, using variables, can you write what the number pattern is here for this number sequence that would work for any number? And here the variable I want to use is the number, or the variable n. So, for example, if I asked you what the 10th term would be, let's go ahead and write an n for that. If n is 10, what would our denominator be? We got to follow the same pattern. What did we have to do to the numerator to get the number in our denominator? We had to add 2 to it. The difference between our denominator with our numerator is 2. 4 is 2 more than 2. 5 is 2 more than 3. 6 is 2 more than 4. So whenever your numerator is n, what will your denominator be? It'll be that same n plus 2. So if n is 10, what's your denominator? 10 plus 2 would be 12. So 10 over 12 is also a number in this number sequence. What if n is 100? What would your denominator be? 100 plus 2, which is 102. So 100 over 102 would also be a number in this sequence if it continued on indefinitely. So we were then able to write the pattern here. Each term in this number sequence follows this pattern: n for your numerator, and then your denominator would be n plus 2. Now, we are not adding the same number to each term to produce the next, and we're not multiplying this by the same number to get from the same term to the next. Therefore, we do not have an arithmetic sequence and we do not have a geometric sequence, but we still have a number sequence here in our last example. What is T3 in our last example? Well, T3, term 3, is 3/5. Lastly, as a review, a number sequence is an ordered set of numbers, and many times these number sequences follow a mathematical pattern, which determines how they are ordered. Next, an arithmetic sequence is a number sequence whereby each successive term in the sequence is determined by adding the same number. And lastly, a geometric sequence is a number sequence whereby each successive term in the sequence is determined by multiplying by the same number. Okay then, that'll wrap up this overview, session 110 on number sequences.